Hello and welcome to this lecture. In this lecture we are going to talk about advanced topic of the Python, which is closures. So closure is basically something to be known as the implementation of the nested function assessing a non-local variable. So before just implementing a closure in Python, we have to first understand what the nested function is and how the non-local variable works with the Python. So if you have ever worked with the nested function, a function that is defined another function is called a nested function. That means you give a function, and if you have a definition of whole complete another function inside that function, then it is said to be the nested function. And nested function can assess a variable of a enclosing scope. So just remember that, because we have this variable as a message over here, that means it can use that message inside this scope, which is our nested outer enclosing function. So we'll just take an example in here in order to see how this non-local variable and nested function work and how this nested function can assess a non-local variable. So in Python, the non-local variable are read only by default, and we must declare them explicitly as non-local using non-local keyword in order to modify them. So in this example, we have defined this outer enclosing function as a print message, and we have this nested function which is over here. That is the definition of this whole function. In this outer enclosing function is our nested function over here. So printing is a nested function which was able to assess this non-local variable, which is message variable over here of this enclosing function, which is outer enclosing function. So if you see here, we have non-local variable which is a message that is passed while calling this print message, but this nested function, which is basically the function which is inside of this enclosing function, has access to this non-local variable message. So this is what we say something like a non-local variable assessment of our outer enclosing function. That is, we can make use of this printer to assess our non-local variable which is message. So we have called this printer inside this outer enclosing function in order to just print this message. So when I just say save this one and press F5, then you could see hello over here. That means this non-local variable message which is of outer enclosing function is assessed by this nested function. So let's see now how this closure can be supported using this idea. So in this example, what would happen if this line of the print message over here returned a printer function instead of just calling it? What we have done here is basically we call this print message, which is basically outer enclosing function. But what if we just return a function that is printer function, this function over here, instead of just calling it? And this means a function is defined by using the closure. So let's see how this closure can be implemented. Let me just give here another variable that is returned from here. So let me say another first. Now instead of just a printer, what we can do here is we'll just say return printer, and we'll just say return printer over here. And now it's time to just call this another over here. So let's call this another. So we have now called this printer function itself instead of just printing the message or calling this outer enclosing function. Let me save this one and press F5, then you could see the hello over here. So this is unusual because this print message function which was called with this string hello, and the return function was bound to this another. So on calling this another, which is this method over here, the message was still remembered. So that's unusual. This print message function was called with this string hello over here, and this return function was called over here, which is only bound to another. So what if I just run this one, save this one first, and run with the F5? And now what if I just do something like delete? That is this delete, and basically it should be all in lowercase. Now what if I just delete, which is print message, which is our outer enclosing function? Let me just delete this one, and if I just say another one more time, the calling of this another, then you could see again the hello. So this is unusual because on calling this another, the message was still remembered, although we had already finished this execution of this print message. So we had just removed this print message, but also it has printed us like a hello over here. So the technique by which some data this hello was attached to this code of this another or calling to this another is called the closure in the Python. So this value in the enclosing scope you can see here is always remembered even when the variable goes out of scope. In this case is a message, or the function itself is removed from the current namespace. In this case we have just removed this print message from the current scope, but also it has remembered our message, which is basically our scope of this function is remembered, or the value in the enclosing scope, which is this message, is remembered even when this variable goes out of scope, or even if the function is removed, as we have done here, deleting this print message. So if I just say print message, let me just go down here and let me say, so let me run it once more, and if I just say something like, let me first delete again, that is our print message from this name scope, and if I just say now that is print message should be called to show you that this print message doesn't exist, and if I just say hello over here, then it is saying name print message is not defined as we have defined here, but we have made use of this delete to delete from its namespace. But when I just call this another again, then you could see hello over here. So this is the way in which some data like hello over here is attached to the code, is the closure in the Python. So you could wonder when we have the closure. As seen in this example, we have a closure in the Python when a nested function, which is this function, reference a value in its enclosing scope to this message value. So let's see the criteria that must be met in order to create the closure in the Python. So let's see first that. So these are the criteria that must be met in order to create the closure in the Python. And first one is you must have the nested function, that is a function inside of a function. That is, in the case we took the example where we have the printer function that is nested in the enclosing function of print message. And the next criteria would be the nested function must refer to the value defined in the enclosing function. That is, it must refer, or it must give a reference to that message that we just created, which was the value of our enclosing function. And the enclosing function must return the nested function, which was the printer in this example. Now let's talk when to use these closures. So closures can avoid the use of global values and provides some form of data hiding. It can also provide a object-oriented solution to a problem. When there are few methods, like one in most of the cases, to be implemented in the class, closure can provide an alternate and more elegant solution. But when the number of attribute and the method gets larger, better we must implement the class. But in this lecture we'll just implement a simple example where the closure might be more preferable than just defining a class and making an object. So you can just remember that closure is an alternative to the implementation of object oriented programming. So let's take the example. So in order to show you how this closure can be good instead of just making classes and object, so let me say make multiplier is our function here, and I'll say multiplier of, and I'll just give here n. So we want the multiplier of this n value, and here we'll just define another function which would be our nested function, and I'll just say define the multiplier, and I'll just pass here x. So after that we'll just return that is x and multiplied by n. So this is our multiplier. So after this we have to just return the multiplier. So these are the criteria to be fulfilled, that is, you have to have the nested function over here, you have to make use of this non-local variable of your enclosing function, and you have to just return this interface, which is basically your nested function over here. So next step is to call or invoke our multiplier. So I'll just say make multiplier, and it should be multiplier. So let me just grab this method over here so that we just remove any error. So I'll just pass here 3, and now let me just do something like printing. So let me just print this times 3. So if you just go over here and save this down and see the output, then you could see it should be removed from here. So what we can do over here is we have written the multiplier, but we haven't called over here, so that should be times 3, and basically we have to pass here 3. So I'll just say make multiplier and I'll say 9. So I'll just give 9 as an x over here. So now we have 9, and it should be 9 multiplied by 2, which should be 27. So let me save this one and run it here. Then you could see 27, which is a multiplier of 3. So you can take another times here, that should be times 5. Let me say times 5, and let me just paste it down here, which is make multiplier function call, and let me just pass here 5, which would be for this n. Now let me make use of this times 5, which is the invoke to our make multiply, which returns this multiply object. Now it's time to just give something like 3. So what we need here is 5 multiplied by 3, and you get something like 15 over here. And you could see 27 and 15 is printed over here. So this was the simple example where we just preferred making this closure, by which we just bind this method to your next element and printing basically the non-local variable, where we make use of this n, and the variable of x is basically your local scope variable, and it will just return this multiplier. So the way or a technique by which this data or value of 9 is attached to this value of n here, which is assessed by this nested function, is the closure. So the value, that is this value of 3 and 5 in this enclosing scope, which is basically the value of n here, for this outer enclosing scope is always remembered, even when the variable goes out of this scope, or if this n goes out of its scope, or the function itself is removed from this current namespace, or this outer enclosing function is removed from this current namespace, it is remembered by this nested function. So this technique is called the closure, Python closure. In the next lecture we'll talk about the decorators, which makes an extensive use of this closure. So see you in the next one.